The way that atomic slot migration works is very similar to how we replicate to our replica nodes from a primary. It goes through three phases. The first phase is this kind of like snapshotting. We fork a child process from our parent process using like the Linux fork. Parent process is still alive and serving. The child process then has a point in time snapshot, and we use that to iterate over the whole key space and send it over to the new node. The new node is storing these keys in a staging space. We ship over the contents and they're inaccessible to users at this point because the slots aren't actually owned on the other side. Phase two is during that snapshot, we're capturing all the work that's happened on the parent process while we're shipping off that snapshot. Anytime there's a change, we check what slot that change is targeting. And if it's in the migration, we just keep a buffer of those. Once we notice that the child process has finished snapshotting everything, the parent process then starts to flush that buffer over to the target node. Once we've flushed out the buffer completely to the TCP stack, we then pause new writes, and this is our finalization phase. We pause the whole source node to make sure that nothing new is coming in. And then we put a marker in our stream to the target node. And then the target can tell this is the point in time when the source node is completely paused and there's no new data. Then the target can take over the slot. It's very automatic. You kick off a migration, then your operator can pull that migration status like a long running operation.